morning children. Today let us see how to measure the strength of an acid or a base. That is, in order to measure the strength of an acid or base, let us study about a term called pH. This term pH means potential of hydrogen. That means strength of hydrogen. This term was first introduced by the scientist Sorensen. Okay, so pH helps us to find out the strength of a substance. In order to find out the strength, we can use a special type of paper called a pH paper. It is nothing, just a filter paper which is coated with a strip of filter paper which is coated with universal indicator. It doesn't possess a particular color, but when you dip in different solutions, it will give you different color. Children, if you just consider the pH, generally the pH of a neutral solution is considered as 7. pH of a neutral solution is considered as 7 and it possesses a green color. When the pH decreases, the acidic nature of the solution increases and you will be getting shades of red. When the pH decreases, you will get shades of red, and when the pH increases from 7, the basic nature of the solution increases and you will be getting shades of blue. Is it clear, children? So acidic solution will give you shades of red and basic solutions will give you shades of blue, and neutral solution possesses a pH of 7. Is it clear? Now pH is actually defined as negative logarithm of hydrogen ion concentration or hydronium ion concentration. pH is defined as negative logarithm of hydrogen ion concentration or hydronium ion concentration. At 25 degrees Celsius, we can say that concentration of hydrogen ion is equals to 10 raised to minus 7 moles per liter. Okay, at 25 degrees Celsius, the concentration of hydrogen ion is a constant which is 10 raised to minus 7 moles per liter. So, if you substitute the values, you will get it as minus log of 10 raised to minus 7. Now, children, log A raised to M is equals to M log A. So, if you substitute this formula, it becomes minus of log, that is minus log 10 raised to minus 7 is equals to minus of minus 7 log 10. And log 10, the value is equals to 1. Therefore, this becomes minus into minus 7, that is 7. So, pH of a neutral solution will be equals to 7. When the pH decreases from 7, the acidic nature increases, and when the pH increases from 7, the basic nature increases. Is it clear, children? Now let us study about the applications of pH. The first application of pH, we can say that pH in our digestive system. pH in our digestive system. You know that our body, in our stomach, hydrochloric acid is there, and this hydrochloric acid helps in digestion. But when the amount of acid increases, it causes indigestion which results in pain and irritation. So, in order to avoid this, in order to neutralize the effect of acid, we can use certain chemicals called antacid. They generally don't have any side effect. The common antacid, we can consider it as milk of magnesia, which is insoluble magnesium hydroxide. That is, aluminum hydroxide or sodium hydrogen carbonate can also act as antacid, which neutralizes the effect of acid, excess acid in our stomach, and thus brings back to the original pH. Is it clear, children? Now the second one, we can say that change in pH leads to tooth decay. Change in pH leads to tooth decay. That is, the enamel of our teeth is actually, it is chemically calcium phosphate, which is quite hard. So normally it doesn't corrode, but you know, that is the sugar particles which is present in our mouth, the bacteria decomposes the sugar and it results in the formation of acid, which brings down the pH of mouth from 5.5, it brings it down. The pH value decreases and that may cause to tooth decay. So to avoid this, children, before sleeping you should brush your teeth with toothpaste, which is generally basic in nature, or this use of toothpaste neutralizes the effect of excess of acid and thus it avoids tooth decay. Is it clear, children? The third application we can say that self-defense of plants and animals through chemicals. Self-defense of plants and animals. For example, if you consider the stings of ants as well as bees possesses methanoic acid. When they stung, they inject this acid into your skin, which causes irritation and pain. Suppose if you, in order to get a relief from this, you just rub that area with little baking soda, that is sodium bicarbonate, which neutralizes the effect of that acid and you will be getting a relief from it. At the same time, we can say that sting of wasp possesses an alkali, and when you are rubbing it with a small amount of vinegar, again you can neutralize the effect of that alkali and brings back the pH. Is it clear, children? So that is again an application of pH. And the last application we can consider pH of soil, that is soil pH and plant growth. Children, if you consider for a particular plant, we need a particular pH. So in order to check the pH of soil, we can do a very simple process. Just take some soil in a test tube or in a beaker and add some water and shake well. After shaking it, you filter the solution and check the pH of the filtrate. If according to the pH, you are checking it with the pH paper, so you can provide the particular chemicals to adjust the pH and the proper pH which help in the proper growth of the plant. Is it clear, children? So that is about the applications of the pH. The rest we will do in next class. Thank you.